Hi guys, thanks very much for tuning into this video, our Ellipse number 2 video, and we're taking up from where we left off last time. So in the previous video we worked through this sheet right here. We worked through 6 problems in total, and starting off with the very basics of given the major and the minor, given the major and the minor for a horizontal and for a vertical ellipse. Then working on from there, given the major and a point on the curve, and given the major, minor and a point on the curve for horizontal, given the minor and a point on the curve and the major and a point on the curve for a vertical orientated ellipse. We then worked on ahead and we talked about focal points and how to establish your focal points by taking half the major from the minor. And then from there we established a use for focal points, and the use for it was in tangents and normals. So we have our tangents and normals here, where we join the focals through and we divide an angle to get a tangent, or divide the inside angle to get our normal. We also had a very brief look at this point right here, and that is the starting sketches, those little sketches that we drop on the page when we're starting a problem, so that before we get into the problem we have our thoughts on paper and we have solved the problem without even realizing it. So when we see that it's a vertical or vertically orientated or horizontally orientated ellipse, we drop in our little sketch straight away. That's what we'll be doing as we work forward. Everything in red here, of course, is something that we had to kind of think of, learn off, or know. So the focal points is half the major from the minor. There's our tangents and how we construct it, there's our normals and how we construct it, and of course at the bottom of that page we had a big long list of keywords and key terms. Now we're going to take it from there and we're working on to some other problems this time, more difficult problems here in sheet number 2. We had 6 drawings last time, but this time we've 5 drawings in total. You're going to lay out the drawings on your A3 page at home, just as I am laying them out here. To get started, if we come down 80 and come in 80 and just get a point on our page for me please. So I'm going to measure on the left hand side down 80 now, and I'm going to take that really lightly. I'll just draw it there someplace, and I'm going to measure in 80. Now that gives me a starting point. Now I don't want much more than the starting point, I don't want a big horizontal line there, so that's down 80 and 80. I'll just get rid of that portion of the horizontal line, and what I'm going to do is draw a line through it. Now I have no idea what angle this line is at, but there we go. So there's a line gone through it at some angle. On that line there is going to be the major axis, and we're going to draw a 56mm circle. So from the center point out 56. And I'm going to draw the major auxiliary circle. Go. The next thing I'm going to do is I'm going to define a point on the curve, and this is a guess, so you're going to keep it somewhat similar to what I have here. The exact position does not matter though. I'm going to come near this corner here and I'm going to work up to where do I think it would be? Where would I like to have it if this was an ellipse? A point on the curve. I'm going to pick one here. Now that is my guess, and it's not in any way important that yours is exactly the same position as mine. Keep it roughly in the same area as mine. Don't go way too close to the curve, don't go way too close to the axis, so keep it somewhere like I did. That should direct me to an ellipse like this. Okay, so there we have it, there's point A. That's question 1, and in question 1 the major axis is given, and point A on the curve given. And just for a little sketch here, what does it look like? And this is really back to the point I finished up there looking at the other page. A very quick and rough sketch there. And that's what the ellipse is going to look like. And that would be our point A right there. And we'll get back to that in a while, just what the importance of that sketch and why it'll kind of come in handy to us. For all of my other questions in the other worksheet, I was just putting a little bit of yellow backing on them to just help the question to stand out. What we would have to do here is we'd have to find the minor axis, and then we're going to go ahead and find, so I'll just write it down beside this, let's find minor, focals, plus tangent. And the tangent is going to be to point A. So we're going to find the minor axis, we're going to find the two focal points, and we're going to find the tangent at A. That's that question. Working on from there, I'm going to lay out another question just over here beside it. I'm going to take, it's down 80 again as a starting point, so I'll take that. I'm not going to draw the line all the way, I'll just draw it here. And I'm gonna just keep this here so that it doesn't go completely out of scale, but I really don't mind what size I make it in a way. I'm gonna be starting there, and I'm well away from the line. I'm not trying to measure exactly what this is. I'm picking a point there, someplace between 90 and 100 mil away. So I have 2 points that are spaced apart 90 to 100 mil. Now those points are the focal points. So that right there is F1, and this guy here is F2. Focal point 1 and focal point 2. I'm going to just move over to here someplace, around there. Okay, and that point B is a point on the ellipse. So let's go ahead and write out this question. Question 2. F1 and F2 given. Point B on the ellipse. Is given. And what type of a curve is it? Well, it is a horizontally oriented curve, just like that. What we're going to do then is we're going to go ahead and find the major, the minor, and we're going to draw the top half of the curve. So there's the question right there. And there's my little sketch to show what way the ellipse is actually facing. Because of course it could be a vertical or a horizontally orientated curve. Next, I'm going to lay out some questions here in the bottom half of my page. I'm going to come up 80 mil from the corner. I'm going to just draw a really light line across the page here. I'm going to come in 80 mil from the left, and from that position I'm going to draw a circle 53 millimeters. So radius 53 set marked there on the axis, and now set on my compass. So there's that one. What I'm also going to add in here is this. This is completely random angle now. My set square, I'm laying it down. I'm not going to go right, I'm not going to go close to the corner. I'll move up along a little bit to here maybe. And I'll do this. And draw a line. That line L right there is a tangent to an ellipse. So the question is this, okay? Question 3, major auxiliary circle given. Major auxiliary circle is given. Tangent to the ellipse given. And what type of an ellipse is this? It's a horizontally orientated ellipse, just like that right there. Now, there's the question. It's the major auxiliary circle is given, and a tangent to the ellipse is given, and it's a horizontally orientated ellipse. So what would we have to do? We have to find, use a method to find the minor and draw the ellipse. So we're thinking about this one now, that the ellipse will touch extreme left and right here on this major circle, and it'll go up, and it's tangential to that tangent line here someplace, and it comes over and continues around. So there's something new for us right there. Next, we will measure in along that same line, that same 80mm high line. We're going to measure in a distance of 210, and from that point I'm going to draw 32 and 51, the major and the minor. So it was 210 in from the side of the page to the center of this ellipse right here, and it was 32 as the minor, and 51 as the major. The major and minor are given, and what we need to do is find the ellipse. First of all, we'll go ahead and draw the ellipse, and we'll go with horizontal orientation again, and then I want to find the tangent at 30 degrees. Okay, so that's going to be the challenge with this question. Major plus minor given. Okay, it's a horizontal ellipse. Find the 30-degree tangent. Find POC. Just like previous rounds there, I'm just going to add in a little bit of colour over the question itself there as well. So major and minor are given. It's a horizontally orientated ellipse. We'll go ahead and draw the ellipse, and then we want a tangent that stands at an angle of 30 degrees, tangential to the ellipse. So that'll be an interesting one. We'll have to find the point of contact exactly there as well. Finally, we'll just measure in from the right hand side here 85mm in to the centre, and we're going to draw our major and minor again at 33 and 56. So 33 for the minor there and 56 for the major. And these sizes don't actually matter really, like they'll change question to question. I'm just setting them up with these given sizes so that I can comfortably get my 5 questions onto the one page. So there's my, I think 33 I think I said, and then 56 for the larger one. And there's one more thing we're going to need here. Okay, once you have your 2 points found, I need a third point, and I'm going to go just up above it to a point somewhere around here, point P. Okay, so question 5. Major and minor given. So major and minor are given, and the point P is outside the curve. It is not associated at all with the ellipse. The type of ellipse we're going to draw a horizontal ellipse again, horizontal ellipse, and we're going to do 2 things. We're going to draw the ellipse, and draw 2 tangents from point P. Now there's a new one again for us. So we'll actually draw the ellipse in its horizontal orientation here, and then we need to find the exact 2 tangents that go to the left and to the right of that ellipse. So a little bit of new stuff to cover here on this page, new principles here, new methods and processes. So it'll be an interesting sheet. Okay, nice build up from the last one. We've all 5 questions laid out now and ready to go. what we're going to do is we're going to let them all alone back here to number 1 and get started from there. Okay, so that's the plan for now. Now here's how for question 1 we need to think back to basics, and I might just grab the sheet from video 1 there for a few seconds and have a look. What's it most like is the first thing I'd be kind of looking at, and I'd say that this ellipse here is probably most like any one of the verticals, or if I just take the sheet around, it's quite similar to this one. You know, it's quite similar to the horizontal ellipse. They're all the same. You just turn, okay? You just turn the orientation around. So for this and this, we could just turn a little bit, just whatever few degrees off vertical that guy is right there. But basically, what we're thinking about is this, okay? Instead of learning this in video 1, that it was down and across only, instead of just thinking in terms of down and across, we should probably think in terms of parallel to the minor and parallel to the major. So parallel to the minor, parallel to the major will serve us in a lot more situations than down and across will. So let's just have a think about this next one here. What's the relation, first of all, between the minor and the major? Right there, that's your 90-degree perpendicular. Okay, 90 degrees are perpendicular. So the major axis to the minor axis is perpendicular. So the first thing I'm going to do is grab sliding set squares and put in my minor axis. So there's the major going up through the object. And there's, oh, that slipped there a little bit, so I'll just check it up. Reset once more. There is the major axis at that exact angle I've set right now, and that is going to be the direction of the minor. We don't know the size of the minor circle yet, but that's going to be the minor axis right there at 90 degrees. I'm going to just drop a little dot on the end point and on the end point. That's where my ellipse is going to touch. The next thing I'm going to look at is this. When we're dealing with this, I'm going to just go back to my initial little rough sketch I had right here. For this ellipse, if I went out with a random line, what would I do? I would come parallel to the minor, and from the circle here, from the minor circle, parallel to the major cross. How does that work for the point we have? We go parallel to the minor, in on center, and across. Okay, so parallel to the minor, in on center, and parallel to the major will give us a point on the minor circle. Now, that's quite small. Hopefully you zoomed in when I was just sketching on that. But let's just get going here and let's see what happens, alright? We're going to go parallel to the minor. So what we're thinking here is that when this was created, or if we were working with a more basic version of this, it would be pressed in from the major at both sides. It would be pressed inwards from the major. So the movement of this object is in and out like this. So that's the way point A, that's where it came from. It came from a point on the major out here. So parallel to the minor, from A out to hit the major is the first move. All of these points are found from lines generating out from the center. So it's my next move, is join the line back in on center. And the second relation that always comes to find the point is across. It'll be parallel to the major this time. It'll be brought out from the minor axis. So let's go ahead and do that. I'll just pick up a different colour fine liner for this job, and take my major and run off from A back onto the green. And there we go. That's the minor. At that stage, we're back to a basic ellipse, except it's turned at an angle first. So, but there's not going to be an issue. We're going to have no problem with that. So there we go now. That's the minor auxiliary circle drawn. You can, if you like, put numbers on these. So going up here with the red was number 1. Going in with the green was number 2. This movement in this way can be noted as number 2, and the third movement in would be your across parallel to the major there as number 3. So if you feel like putting some notes, and if you think that might help you when you're coming back to study this or to check it out, if you're doing a hard exam question, then go ahead and do that. The next thing I'm going to do is I'm going to break it up using my 30 and 60 degree set square. I'm going to break it up into my 12 segments. Now it'll overlap here a little bit. We'll see how we get on. What I need to do though is this. Okay, I can't just bring in my T-square. I don't like that because it's not a vertical or horizontal main axis. It's also not a 30 degree main axis. So I don't like basing it on my T-square this time. What I will base it on is I'll base it on the axis that we already have. So I'll take that axis, okay? I'll take that axis right there and I'll just slide away parallel to that. So I have the angle of my minor. I'll just bring it on down there, okay? And based on that axis, I'm going to do all of my divisions. So through the center, I'm going to do all of my divisions now, okay? Or as many as I can off this particular position right here. So I'll break up. And again, I'm just being very careful here that my 45 degree set square does not move. And if it does, I will just reset. And this one is already done. What's missing? Oh yeah, just this last one right here. Down at 60 degrees. So now I have 12 equal divisions based on the angle of the minor axis. Or I could have gone with the angle of the major axis, of course. I have already said there a while ago that this ellipse was formed by compressing in until it reaches the minor here, and in until it reaches the minor here. So we now have the 4 points on our ellipse and one additional point right here. So let's go ahead and get this thing finished, okay? We're compressing in from all of these outer points, in and in parallel to the minor, and in again here. So that's the first thing I'm going to do. I'm going to set up in line with the minor right there. And I'm going to start down here and I'll compress in and in. And I can do both sides at the same time. So in and in. And now that's going to get a bit busy there, but that's okay. In from the major. There we go. That's the first one done. First part of the construction done. I'll just rub that out. I don't like when my lines come across and hit through the axis or anything like that. There's no need. I'm going to go in line with the major here, and I'm going to go from the minor out, and hopefully, yeah, we're lining up nicely there. From the minor out, and same here on this right hand half of it. And once we get that much constructed there, we can I'm going to just go ahead with my fine liner, and the only reason I'm doing this is for the video. You would not really need to do this on paper yourself at home, but they are all the points on the curve, so trying to freehand it in. So basically join the dots with a nice neat freehand curve if you can, and try to get into the habit of creating freehand curves here and getting them as tidy as you can. There we go. Now what I did say is I'd like to find the minor axis, the focal points and the tangent on this. So let's go ahead and find the focal points. First of all, minor axis is found, ellipse is obviously found. So minor is found from taking half the major from a point on the minor on the curve, and there we go. It has to be within the curve as well, so I wouldn't do anything like this, going to the minor and bringing it outside. That doesn't exist. That's part of the construction. There's the ellipse, and the focal points have to be within the ellipse. So I get F1 up here, and I get F2 down here. because there's already enough going on here, I'm not going to add in any extras right there, but I'm going to pick a random point here, okay, and that random point I'm going to create a tangent at that point right there. So I'm going to do that by joining my two focal points through the selected point. Join one and the second, and there we go, that's joined up. And bisect the angle. Now, which angle do we bisect? Well, if we wanted a normal, it would be standing straight in from the curve, so we would bisect this internal angle. If we want a tangent, we want it coming out here through that way, so we're going to bisect the external angle right here. So I'm going to go and get my compass in the point in the corner. I'm going to open up, and the larger you go, the more accurate it is, and as long as you don't move the compass like I just did. You get 2 strikes on your 2 focal lines. Open up again. You can change it or leave it the same, whatever suits you. And there we are. That's my tangent finished. So that tangent is from the point on the curve to the crossing point, intersecting point of the 2 arcs right there. And there we go. There's our tangent. Now, that is that first part of this finished. That is a tangent to the curve at point, what have I used? I'm going to call that just point P right there. Tangent to the curve at point P. So there's an ellipse drawn that has a major axis at just some random angle. Now that could be given as a 60 degree, 45 degree, 75 degree. It could be anything at all. It will not change the principle in the process that we've just covered. We're going to move on next here to given a focal point number 1, focal point number 2, and a point on the curve. Very, very common question that would come up as a short question. So you'd have your about 6 or 7 minutes to get this answered here, and or less than 6 minutes even, and quite an easy question when you just know one simple little bit of theory. Now, the bit of theory you need to know is this. The sum of the focal distances is equal to the major axis. And I'm going to write that down as a note here beside it, okay? So the note here is the sum of the focal distances, the sum is equal to the major axis. Now, I'll just put a little bit of colour on that there, because that's a key little piece of learning, so we put a bit of red on that. What does that mean? Well, it means that the sum of the focal distances, the distance from a focal point to a point in a curve back to a focal point, is equal to the major axis. So if I add the 2 lines together, so if I can join the focal to the point and the point back to the focal, the sum of those 2 lines added together is the same size as the major axis. So let's go ahead and do it and prove it and see how it works. I'm going to start off here by joining each focal to that point B right there. Point B being a point on the ellipse. So first focal to point B. And I'm going to add some colour to it as well with the fine liner, just to make sure it stands out nicely there. So focal to point B, and I'm going to go for the second focal to point B right there. Now when I take the combined distance, the combined totals of focal to B added onto B to focal, I can add those 2 red lines together. That is the size of the major auxiliary circle. What I'm going to do is I'm going to graphically add them together. I'm not going to measure one and measure the other and add them. I'm going to add them together using just my drawing equipment like this. I'll put the compass at point B and I'll take the length of that second line here and I'm going to add it up here. Okay, so that's on that curve right now. I have taken the length of the line from B to the focal, and I'm just swinging it up, and it's going to fall directly in line with the original line right here. So what I now have is this one here. Gives me full distance from here to here as the major axis. So very handy way of doing this. Now before I do anything like that, I need to find the center of my drawing. The center of the drawing is going to be between the focal points. So I'll just grab the compass nice and quickly, and I'll bisect there between the two focal points. I don't need to bisect above and below the line because I know that that's a horizontal axis, so I can just go vertically up there to center. That's the center of the two focal points, and that means it's the center of the whole ellipse drawing. Now what we're looking at here is this. As I just did right there, I took the line number 2 here, B to F2. I took that line number 2 and I just swung it up to this position here where it's directly in line, and I have combined the distances into one full line. Now that's the major axis, which means it's the diameter of the large circle, but diameter is no good to me. I need radius, so I'm going to go ahead and bisect that line. Now don't get mixed up with what I did down here. That is finished. I'm going to bisect the line that goes from the focal, and I might just put a different colour here, starting and end, so that we get this. I'm going to bisect the line that goes from that point on focal 1 to that point there at the end. So compass opens up to more than halfway. I'm going to swing up and down because it's a slope line. Leave it set the exact same. Swing down and up. And bisect the line. That bisector gives me this. It gives me a radius for the major, which is the same if I set it to the left or to the right. So that's half of the combined distance there. That's the radius of the major. I need to go back now onto the center of my drawing. So I have my compass set. There's the center of my drawing. I'm going to go from the axis, and this time I'm only going to draw the top half of this drawing. So there we go. There we have it. Okay. So that's the major circle, and I found that by taking half of the combined focal distances, which was from blue point to blue point. I swung it from the center of my drawing all the way around. The next thing I'm going to do is just, actually I might just tidy this guy up a little bit. That's a very big arc there getting in the way, but I'm going to draw a central axis up through this guy right now. So I have my major already found. I'd like to find my minor, and like we had in the last sheet, half the major from the top of the minor gives us a focal point. Well, this time we're going working it the opposite way around. I have half the major there, but I don't have the top of the minor, but I do have a focal point. So I'm going to hit it down there on the focal point. That's the minor right there. I'd like to prove it, to go to the other focal point and strike it. That's the minor. So half the major usually is from the top of the minor down to the focal, but this time we're working backwards from the focal up there. So that's the minor axis. So I'll just change the setting in my compass. I'll open it up until I am just there, and I am barely falling inside, just about falling inside the focal points there. And that's okay. That's the way my question worked out. It's fine. But there we go. So that's the major and minor right now. So using my half the major from the top of the minor rule to find, this time working backwards from the focals. So just go ahead nice and quickly and split this, break this guy up. Now, chop down there. Let's clean up that guy just that little bit, and that is it. There's quite a bit in that now, you know. So our little rule here that's feeding in from this side is there. And if you'd like, I think it would be a great idea to have some notes here on how you solve this. So adding the focal distance to the total, finding the blue major, bisecting it here in the center, bisecting the focal distances, swinging your major, and then working back up from your focals up to your minor. So that's that one done. As I said there at the start, I really want to emphasize that's a very, very popular question in the Junior Cert short questions. It can also come up as part of a long question, of course, but very popular choice as a short question. On to number 3, the major auxiliary circle is given and a tangent is given. And what we need to know about this is this much, okay? There's a relation here, okay? And if I set, first of all, I'm going to set the angle of my tangent and use my sliding set squares. So if I set the angle of my tangent, and if I slide and draw perpendicular lines from the points where the tangent, actually first of all we'll just outline our 2 points. The points where the tangent intersect with the major auxiliary circle can be ran off at 90 degrees to find the focal point. Let's check that move now. Seem to move slightly, yeah. And run off again, 90 degrees to find the focal point. So there's another rule, okay? You go perpendicular from the points where the tangent intersects the major. So I'm going to take note of that, perpendicular. There we go. So that's our little bit of key learning for this one here. We go perpendicular from the points where the tangent intersects the major to find the focal points. So there we go. That's just a little extra key rule that we have right there. And that is a constant in our conic here in our ellipse. So perpendicular from the points where the tangent intersects the major circle give us our focal points. So we're solving another question now. And we're kind of relating this back to our knowledge again here. And there's focal 1 and there's focal 2. We've just come across something similar. We don't have a minor, but we do have a focal. Again, usually it's half the major from the top of the minor down to the focal. This time we reverse the roles. Half the major from the focal should give us the top of the minor. There. Let's just see how accurate this is. By drawing the minor axis perpendicular to the major. Does it go through the point? Yes, it does. So that gives me my minor right there. Okay, so that's the minor auxiliary circle. I'll draw that a little bit heavier so that it definitely comes out in the video. Comes out clearly. I'm going to just quickly go ahead and draw the ellipse because I need to find the correct point of contact as well. Now, there we go. Now the last part of this, as I said, I should have noted this in the question, so I'll note it now. Find what? What do we have to find here? In this question, the total question, we find the focal points. PTS, short for points. Find the minor. Draw the ellipse. And most importantly, is find the POC. Find the point of contact between that given tangent and the ellipse. So what we do there is we double a focal distance, okay? And it's probably going to get slightly muddled up here with the next question, but we'll see. It mightn't be too bad. We're going to double this focal distance from the focal out to the major. Okay, so I'm going to go ahead and double that. Take the focal distance here and take it and swing it around. Double your focal distance. So I'm taking the green line and swinging it around to here, and then join that back to the second focal, and that gives me the POC right there. So there's something else new to learn. You double the distance from the point on the major into the focal, straight out in line, swing it around, that's your distance doubled, and join it back to your second focal, and there you go, that's it. Would work the same way if you doubled this distance right out to here someplace and joined it down. You catch the same focal point or point of contact along the way to this focal. So that's it. Let's see this one here. Major and minor are given, and we have to find the 30-degree tangent. So we're going to be using the same information to find the 30-degree tangent over here. So again, I'll just go through, first of all, draw the ellipse. And we're getting loads of practice at drawing ellipse here, which is great. There we go. There's the ellipse drawn in. Now we have to find the 30-degree tangent. For any tangent we're going to need some focal points, so let's go ahead and find them nice and quickly. Take half the major from the point on the minor on the curve, so it's not going to be these two because it's going to be one of these two. So point on the minor on the curve is there. So I get focal 1 and focal 2. And I'll just drop those in, label them F1 and F2. Really doesn't matter if you want 1 right and 2 left, that's fine. No, whatever configuration you want will work. What we'll do is this. This line is a bit unnecessary. I'm going to drop it in anyway. I think it aids a bit of understanding at the beginning. Like this. I'm going to drop in just maybe a red line at 30 degrees just outside here. Okay, now that's not a tangent because it's not touching the curve. But what I need next is, from my focals, I'm going to just run up perpendicular to the line. So this time it's easy, it's 30 degrees, so 30 and perpendicular 60. From the focal point up to the line, from the focal point up to the line. Now the line is completely unnecessary, but what it does do is it just allows me to say, right, I know that that line is 30 degrees. Okay, so that's a 30-degree line, any 30-degree line. So it's parallel to the tangent. And I can see straight away graphically that them two lines that I just drew in green are normals, they're perpendicular. So that's perfect. What that gives me, it gives me a point on the major and a point on the major. And from those 2 points, I can draw the real tangent. So, there we go. From those 2 points we draw the real tangent. So that's the correct tangent. Last move. What about our point of contact? Now this is where we just need to be really careful that we don't use the excess line that's out here or the excess line that's out here. Okay, they are not a certain or specific distance. What I'll do is I'll just switch maybe to a pink colour for this one. I'm going to take, last time I just doubled my small distance here. This time I'm going to double the larger distance. I'm going to take the distance from the focal to the major, and I'm going to double it. Out along here, I'll take the distance from the major into the focal, and I'll bring it around. And that gives me this point up here. That point then joins back down to the second focal, establishing POC right there. Now, that's that question done. 30-degree tangent, or of course that can be a tangent at any given angle. So we, first of all, if you want to and if you're comfortable to, drop in a line at 30 degrees just outside of the question. If it's a random angle, then we might have to use sliding set squares, but no matter what, if it's 30, it's 60. If it's 45, it's 45 in. We run off perpendicular to that line from the focals, and that gives us the 2 points on the tangent that are on the major auxiliary circle. We double one of our focal distances, and of course not adding on or not including this extra space out to the red line, but we double one focal distance out to the point on the major. We double it up and join it back to the second focal point, giving us a point of contact. Last question here for this. Major or minor are given. We need to draw the ellipse first, and then we need to find some external tangents. So I'll go ahead and once again get to my practice in at drawing the ellipse first of all. This time I'm going to go ahead and do a vertical ellipse, not a horizontal. Okay, just for the change. A vertical ellipse works like this, compressed in from the sides. So, using the same rules, we go in from the sides. And next thing we need to do there is just find the focal points, same as always, because if you're talking tangents, we need focal points. So take half the major. And again, we don't want to fall in the trap here. So it's not going to be from this point because it is on the minor, but it's not on the curve. It has to be a point on the minor and the curve. Gives us a focal and a focal. And there we go. So I'll just change my sketch on that question there to a vertically orientated, just because I'd like to get some more practice in with the vertically orientated ones as well. Now, where is the last, what is the last thing we're asked to do? The last thing we're asked to do is this. Don't draw this. Find the tangent that runs from P and touches on top. And there'll be a second tangent from P that will go down and hit somewhere very close to the center there actually. Which is unfortunate, but it's going to be really close to that center. We need to construct correct points of contact to do this. So we have a couple of steps. Step number 1. This is for tangent from external point. Tangent from a point externally from the ellipse. So on the ellipse and external, that's our two things. So swing from P to F1. Okay, so put your compass on the point P, open it up to the focal point that is close to you, and just swing. Okay, and swing around both ways. I hope I don't run out of paper here. Hopefully not anyway. So swing. That's number one. And I want to just again break one of my own rules, which I don't like doing. I'm going to just go ahead and add a little few dashes there. And what am I swinging? I'm swinging from P to F1 as the radius for that arc. Next, point number 2. Swing major from F2. So take the major axis, full major now, not just the major radius, it's the major axis from the second focal point. And there we go. And again, break my own rules. So swing them from the second focal point. And then point 3. Join A and B. We'll see where A and B are now in a second. To F2. A and B are where the curves cross. Okay, we're going to join them back to the second focal point. A, back, and B, back. Now, where those points crossed the major, number 4, mark your POCs. Mark your POC. So where them green lines cross the major, mark your POC. And where did it cross here? Yeah, more or less on that point is our POC. And it's the point of contact for the tangent from point P, going down, touching at a point and moving on along. And from point P, going in, touching at a point and shooting along. So there's our method for finding tangents from a point external to the curve. And I should of course add some, sorry, that will be red of course this time, because it's a bit of key learning we need. Yellow is the question and the red is the key learning. So tangent from a point external to the curve is given right there. That's our process that we need to learn. Now that's a good bit of more practice there, so there's a lot more to do here for this sheet. It's going to take a little while to work through this at home. Everything has worked out quite well there on the page. Everything fits. It's a busy page, there's a lot going on. You've now learned about working with major axis and minor axis and ellipse, where it's not vertical, horizontal, and it might be turned at an angle. You've learned our principle of the focal distances to a point in the curve adding up to equal the major axis. You've learned also in this where you're given the major and a focal point and you can establish a minor. You could also of course be given a question where you're given the minor axis and a focal point and you have to find the major. Same learning applied in a different way. You have a major and a tangent given and you have to go ahead and find focal points, the minor, draw the ellipse and find the exact point of contact. We had our major and minor given here and you had to draw your 30-degree tangent, so a tangent at a given angle. And finally we have our ellipse given and we had to find from an external point, find the two tangents that touch that given ellipse. So I'll just take note of those guys as tangent. Tangent number 1 and tangent number 2. If the tangent is a point on the curve. If it's from a point on the curve, there's only one possible answer. But when it's from a point outside the curve or an external point, there's two possible answers always. Now, that's it for video 2 on the ellipse. I hope this has been helpful and interesting. I think if you all go ahead and finish out this sheet the same as the last one, you're going to have 2 really good sheets that you can come back to and revise or see some of your key notes and key learning from if you happen to get stuck with any difficult questions in the coming while. Thanks very much for watching. Make sure to give it a thumbs up and subscribe to the channel if you haven't already, and there'll be more content coming on Ellipse soon. Thanks very much.